Hi, everyone. Welcome to our Consortium for Monitoring, Technology, and Verification workshop. It's great to be here today and to tell you a bit about our year 2 accomplishments. So as you can see in the photo on the slide, we were together in March of 2020 for our year 1 workshop, and the world really changed in the year from that date. We had lockdowns and dealing with a terrible pandemic, and I hope that everyone on this call is safe and their families are safe from the pandemic. Hopefully we'll get over it soon with the vaccine rollout. And as important as the pandemic has been in the past year, we still have our mission in the MTV, which is that of preventing the further spread of nuclear weapons around the world. This is still a very important mission, and we want to make sure that we are training the next generation to be able to rise to that challenge. So in our consortium, our motivation has to do with preventing not only the spread of nuclear weapons, but also technologies that are used to develop those nuclear weapons, and also detecting proliferation at any time when S&M is being developed, and looking at the fuel cycle and looking at material detection at all stages of the fuel cycle. So our mission is to develop new technologies, to detect and deter proliferation activities, and also to train the next generation of scientists and engineers with the talent and passion in these areas. So the training the next generation is very important. The National Laboratory Complex, where a lot of this work is done, is experiencing a large hiring demand. So they're in need of scientists, engineers at the master's and PhD level that could be hired to work on these important issues. So our consortium has the objective to develop the technologies, but also to develop that talent and trained individuals that can help in this mission space. And so here we're looking at multidisciplinary education programs that are required. To give you an idea of what a consortium like this can accomplish, I have here the graph of the 60 PhDs and postdocs that were trained and transitioned to various national laboratories, industry, academia, the government from our CVT effort. So this is the effort that just concluded this year. And you can see that we have 60 folks, and many of them are in the room here today. This slide shows the leadership and organization of our consortium. You can see the leaders there on the left, our external advisory board, consisting of leaders in the national laboratories and university and organization across different thrusts. So you can see the 3 thrust areas: the technical thrusts, looking at the fundamentals of nuclear and particle physics, the signals and source terms for nonproliferation, and the nuclear explosion monitoring. And for each of these thrusts, we have a thrust area lead, and in each of these thrusts, we have multiple projects working on different aspects of these thrust areas. And we also have cross-cutting thrusts, looking at modeling simulation, policy, and education and outreach. This is the timeline of our consortium. It's a 5-year effort, and right now we are in year 2 of this effort. And the year 2 has to do with development of the state-of-the-art nuclear nonproliferation technologies. So we started up in year 1, now we're in year 2. In year 3, 4, and 5, we will further develop, apply, and transition these technologies. The outcomes that we expect over these 5 years are over 100 PhD and master students trained, over 100 undergraduate students, and then outreach and development into over 1,000 elementary, middle, and high school students at outreach events at our various institutions. And then we also have technology output with it, which is new science and technologies in nuclear nonproliferation and security area. When we think about starting this new MTV consortium right in the middle of a global pandemic, and we were just wondering, how would that affect our outcomes in the first year? And we compare here in this table the outcomes from the CVT, our previous effort, and the MTV, which is our current effort. And we can see that we are faring really well in terms of the number of students that we have hired onto the consortium, the number of peer-reviewed journal publications, the number of presentations, invited talks, and so on. So that is very encouraging. During the first year and second year, we have responded to the pandemic, and several of our institutions have actually been very nimble in looking at our research a little bit creatively and helping with the pandemic response. And so here you can see the efforts at the University of Tennessee in Knoxville and at MIT, where researchers there worked on looking at wastewater monitoring to determine which buildings in a given campus or community were affected by coronavirus. And so you can see here that Terry Hazen chaired an expert committee on best courses of action for testing and wastewater-based monitoring of COVID. In my group, we have a linear accelerator, and we explored ways in which that LINAC could be used to sterilize various PPE that could be contaminated with the virus. And so you see here that we published an IEEE Access paper on a review of various sterilization techniques. During the pandemic, we were able to perform experimental activities thanks to our collaboration with our national laboratory collaborators. So that was really encouraging to see that we could continue that experimental activity even when there were a lot of shutdowns. And here on the slide, we are highlighting a few of these activities. So you can see the Savannah River National Lab hosted us in November of last year with experiments on special nuclear material and imaging of these special nuclear materials. You can see here an example of one of the experiments where we had a mock HEU source and a plutonium disk measured by an imaging system that we developed. On the right there, you see an experiment that occurred at the University of Michigan using a californium ion chamber that was borrowed from our collaborators at Oak Ridge National Lab, and studying the physics of fission by using this type of source in an ion chamber. And at the bottom, you see an example of activities performed at the device assembly facility at the Nevada test site, where we are running both subcritical and critical experiments and testing the detector systems that we are developing within the consortium. So I'd like to now transition to a few student highlights from research that our students are performing within our consortium. You can see here the work by Val Wadei at the University of Michigan, and you can see her work looking at imaging and using CZT imaging detectors in a new way with algorithms that are based on region of interest, maximum likelihood expectation maximization, that are able to image a plutonium beryllium source, in this case, which is a distributed source. And the results show that she's able to image the 4.4 MeV gamma ray from the plutonium beryllium source and able to see the distribution of the source in both directions, both on the x-axis and on the y-axis. And so this is very encouraging result. Another student highlight is from Ethan Klein at MIT. And Ethan is working on a neutron resonance transmission experiment looking at epithermal neutrons in the energy range of a few tens of electron volts, and looking at how various isotopes attenuate a beam of neutrons in those energy ranges. And by studying those attenuation dips, Ethan and his group are able to determine the isotopics of a certain special nuclear material object. So this is really interesting because then we can determine the enrichment level, for example, of a uranium object by studying these transmission data. And the third and final student I want to tell you about is Sam Takazawa, and he's at the University of Hawaii, and he is looking at a number of acoustic explosion data from a number of events that were given to him by our collaborators at Lawrence Livermore National Lab. And by having all this data, he's able to develop a artificial neural network that can analyze the data and determine from this data the depth of the data, whether it's below ground, it's above ground, or at ground level, and also the yield of a given explosion. And so by using the neural networks, we're able to predict where this explosion took place and what the yield of that was. So these are 3 examples of our students, and you can hear more about them in the talks that will follow, and many more, of course. I want to tell you about our peer-reviewed journal publications. A lot of the work we do is published in the open literature, and you can find it on our website in terms of what we published a given year. And we have had 48 peer-reviewed journal publications since we started in September of 2019. And you can see the breakdown of those 48 publications across the 3 thrust areas. And I want to highlight here one paper that came out of Professor Jovanovich's group on Optics Express, looking at filament breakdown spectroscopy, where we are interrogating a sample of material with lasers and able to then detect the emissions from that material. And the idea here is to detect S&M at a distance. Big part of our consortium is to educate and engage students, and we have 163 students and postdocs in the program right now. You can see how they're divided up here. We have 71 undergraduate students and 86 graduate students and 6 postdocs. Of these, we have 64 that are fully funded by the consortium, and we call these fellows. And 99 of these students are working on consortium-related projects, but they're not fully funded by the consortium. And we call these associates. We run workshops, including the one that you're in now. We also have other workshops, like the workshop on MCMP, the Nuclear Engineering Summer School, JAMP4 training courses, and we have an upcoming workshop that has to do with US and UK collaborations and looking to increase these collaborations. We're also really interested in early engagement. We know that these topics are frequently not taught in schools, and so we'd like to improve that by bringing in early students in elementary, junior high, and high school students, undergraduate research fellowships, and activities like building your own Geiger counter for radiation detectors with young adults. For the public, we're also very interested in reaching out to the public. And so we have activities like our radiation weather station, where we can detect and give out information about the radiation background in a given location. And our website is also a source of information for the general public. The MTV Nuclear Engineering Summer School that I mentioned earlier was a highly successful program that we held this past summer. It was initiated by our students, and it's a 12-week program developed to strengthen the student research capabilities, bringing in a lot of interesting topics in nuclear engineering and detection, and analyzing experimental data, also looking at bringing in guest lecturers from our national labs and other universities to talk about these topics. I want to highlight a few of our student awards that were during the pandemic. These happened, and these are really great opportunities for our students. Lauren Nagel was awarded the Marie Curie Fellowship from the IAEA. Tyler Johnson was accepted to the Stanford US-Russia Forum as an Arms Control Fellow, and Katie Muma won the first place in the JD Student Paper Award, and Nathan Giha, NSF Graduate Research Fellowship. So congratulations to all of these students. So I want to finish with our recent accomplishments and talk a bit about these. You will be hearing a lot throughout the next 3 days about all of these accomplishments. We have 163 students recruited into the program. We have, for each of the TAs, several highlights: developing high efficiency array for characterizing fission, looking at experiments with californium and demonstrating competent imaging reconstruction for locating sources. We demonstrated laser-induced fluorescence as a technique for detecting heavy metal content in moss, developed the epithermal neutron capability, spectroscopy. We casted and characterized organic glass scintillator for an improved beta cell, and improved discrimination models based on Soviet underground nuclear explosion data. So with that, I'd like to conclude and want to thank our sponsors for the support of our consortium. And I hope that you have a great 3 days with us during this workshop.